Good morning, friends. Welcome to this session. Today we are discussing the surface tension and its explanation. As we know that a liquid has a tendency to reduce its surface area to a minimum, and hence its free surface is in a state of tension. This pull or tension in the liquid surface is known as surface tension. To understand the surface tension and to set the equation, take a drop of liquid. Let us imagine a straight line AB of a length L that is drawn in the free surface of a liquid. Then on account of tension of the liquid surface, the molecules on the two sides of the line will have tendency to pull away from each other. The direction of the pulling force is at right angles to AB, and the tangential to the liquid surface. The magnitude of this force is at right angles and is found to be proportional to the length of the line. यहाँ पे अगर F हम जो फोर्स कंसिडर कर रहे हैं और वो राइट एंगल्स टू आइदर साइड ऑफ लाइन A and B, then we can write F is directly proportional to the L, because capital L is the length of AB and the tangential force acting on the line AB. So what action takes place on the liquid surface? There is a tension produced on the free surface. It means if F be the force acting at right angles on either side of the line AB, F is directly proportional to L, where T is the constant for liquid at a particular temperature. This constant is called the it is called as the surface tension of the liquid. So we can write F is equal to TL, then tension is equal to force per unit length of the line. If L is the unit and that is having 1, so F is equal to T. So can you define the surface tension? Yes, obviously we can define. The tangential force per unit length acting at right angles on either side of a line imagined to be drawn in the free liquid surface in equilibrium. What action of the force at the boundary of the liquid surface? The force of surface tension acts inward only, whereas the other places in the surface it acts on either side of the imaginary line. So the magnitude of the surface tension depends upon liquid and its surrounding medium. If the surrounding medium is not stated, then what? It is supposed to be air. So the SI unit of the surface tension is Newton meter per, and its dimensional formula is mt raised to minus 2. The CGS unit of the surface tension is dynes per centimeter. So at the boundary of a liquid surface, the force of surface tension acts inwards only, whereas at the other places in the surface it acts on the either side of the imaginary line. The magnitude of the surface tension depends upon the liquid and its surrounding medium. The SI unit of the surface tension is Newton per meter, while the CGS is dynes per centimeter. Now what action takes place in the liquid? The tendency of the liquid surface to contract to a minimum possible area, and it has suggested it is in a state of tension. That is called a surface tension. Now we can explain the property of liquid on the basis of molecular theory, which was given by Laplace. So in this figure, there are three molecules A, B, C, and with their spheres of influence drawn around them. Then the sphere of influence of A lies completely inside the liquid. It is equally attracted in all possible directions by molecules within its sphere of influence. So what is the resultant force acting on it? The resultant force is what? Can you imagine or can you explain? There is no resultant cohesive force acting on it. Suppose we are considering the C molecules. A molecules balances while the C molecules are free to the air. Some portion is there. It is exactly half. So in the air we can imagine, just imaginary part is there. There is a partially outside, means the sphere of influence lies partially outside the liquid. Now the number of molecules in upper half attracting the molecule C in the upward direction, and that is less than the number of molecules in the lower half attracting it in the downward direction. So what is the resultant downward force, or what is the nature of that resultant downward force? It is always acting on it. So that is the downward force is acting on it. Now consider the sphere of influence B here. The sphere of B is partially minimum area is outside the liquid surface. And when you are comparing to this one, the sphere of influence C is exactly half outside the liquid and exactly half inside the liquid. Hence this molecule is attracted in the downward direction. When it is directed downward direction, what is the force? This downward direction, the molecules is attracted in the downward direction with maximum force, and that is perpendicular to the surface of water. Now just draw imaginary line from this portion to this portion, means exactly from यहाँ से हम एक ऐसी लाइन ड्रॉ कर लेते हैं जो यहाँ से पार्शियली नीचे जाता है, पार्शियली ऊपर जाता है, जस्ट इमेजिनरी लाइन, and that is parallel to the free surface. So just consider here is P, Q is the free surface, while the imaginary line draw, that is the radius to contacting with this line molecule here, and exactly half of this one. And this is the distance between the two lines which are parallel within the molecular range or equal to the molecular range, means this distance is equal to the molecular range. Then the layer between the molecules or the planes PQ and RS is termed as, यहाँ से लेके PQ लाइन और RS, इन दोनों का डिस्टेंस कैसा है, विद इन द मॉलिकुलर रेंज है. अब इस दो लाइन के जो सरफेस को, दैट इज रेफर्ड एज अ सरफेस फिल्म. नाउ द क्वेश्चन arises, what is true for molecules B and C? Is it true for all other molecules in the surface film? What is the nature of that molecules in the surface film? They are pulled downward due to the resultant cohesive forces, the magnitude of which increases from surface RS to free surface PQ. Now consider the molecule from the interior of the liquid is brought up to the surface film. Work has to be done against the downward cohesive force on it, and its potential energy increases. Therefore, the potential energy of the molecules in the surface film is greater than the potential energy of the molecules lying below it. मतलब यहाँ का जो सरफेस एनर्जी का, सरफेस फिल्म के ऊपर का जो पोटेंशियल एनर्जी होता है वो ज़्यादा होता है कंपेरेटिवली बिलो द सरफेस फिल्म. A system in equilibrium has a tendency to acquire lowest possible potential energy. Thus, to decrease the potential energy of the molecules in the surface film, what happens? The potential, when it is acquires the lowest possible potential energy, thus to decrease the potential energy of the molecules in the surface film. What is the nature of that decrease of the potential? The film tries to have minimum number of molecules in it, and this can be done only by decreasing the surface area of the film, because its thickness is already fixed. How much it is? It is equal to the molecular range. This is the reason why the free surface of liquid always tends to have minimum possible area. When the molecules are inside the liquid, they are attracting within all possible direction, while partially or exactly half they are pulling downward direction. Here the potential energy of the molecules in the surface film is greater than the potential energy of the molecules lying below the surface film. So we can define or we can explain what is the surface energy. As we know, the potential energy of the molecules in the surface film is greater than that of those inside the liquid. So the excess potential energy per unit area of the film is called its surface energy. So we can define the surface tension with the help of work done per unit area, because this surface energy of the increased surface area, that increased the surface area of the film, so we can define it the amount of work done in increasing the surface area of liquid film by any other molecules or by any unity under the isothermal condition. The surface tension can thus be expressed in joules per square meter. So this is the surface tension explanation. Suppose we are taking the example, do you know the camphor? कपूर जो होता है ना, जलाने का कपूर, उसका छोटा टुकड़ा लेते हैं हम उसको और क्लीन सरफेस ऑफ वाटर के ऊपर उसको रख देते हैं. जैसा भी आप उसके ऊपर रखते हो तो क्या होता है, द कैंपर मूव रैपिडली in different direction. Particles of camphors gradually decreased, or what we say would dissolve in water and lower its surface tension. इसकी वजह से कैंफर पुल्ड होता है टुवर्ड द सराउंडिंग्स water of a higher surface tension. As the particles dissolve more quickly at some points than at others, the force due to the surface tension at all points is not uniform. अब समझो हम क्या करते कि एक ऑयल ड्रॉप लेते हैं हम, that is how we are explaining the shape of oil drop in a mixture of water and alcohol of the same density. यहाँ पे क्या होता है, if a drop of oil is placed in mixture of alcohol and water, the same the density as that of the oil, so weight of the drop is exactly balanced by the upthrust of the mixture, and thus the effect of gravity on the drop is completely cancelled. Hence here the only force governing the shape of the drop, and it is that due to the surface tension. Then what is the potential energy of the drop due to the surface tension? It is the minimum. When its surface area is the least possible, since a sphere has a minimum possible area for a given volume, the drop acquires the shape of the perfect sphere. So this is the explanation and examples of the surface tension. I hope you understand better. So thank you very much for watching this video.